I want to talk about completing the week 4 project, confidence intervals and hypothesis testing, using the online version of the StatDisk program. So let's go ahead and we'll get started. And as you have hopefully gone through the material on confidence intervals and also hypothesis testing, that you'll know that they're really tied together very well. It's just a different way to kind of look at things. Um, Confidence intervals may be a little bit of an older idea in statistics, and then the more standard techniques used nowadays, we adjusted this idea of confidence intervals and turned it into a very standardized process that people use all the time in all kind of areas in every field. So very important ideas in statistics. Now, so we need some data, and it says here to open the file garbage weights, and we go into data set and all that. So let's go ahead and we need to pull up StatDisk. And so here's the, when you go into stat, and you should be getting familiar with the program. So you go to www.statdisk.org and then sign in. And so you should be kind of used to that by now. And this is the opening page. And um, again, if you have any issues with how to use it, down here you'll see StatDisk 14th edition. There's a user's manual there and some instructional videos here. And if you select up here at any time while you're working through, this appears during the opening page, but it's also over here on the right. You see you can get into the user's manual and videos and so on over here also. So we want to get into data sets, and let's see. So we're going to get the garbage weights, and we're going to go into data sets, elementary stats, the 13th edition. So data sets, 13th edition, and we're going to get on to garbage weights. There we go. And then it puts a bunch of data in here for us, and we're going to use that to create some confidence intervals and do some hypothesis tests. So again, I'm going to have to kind of go back and forth here. And again, it's just number 2 here just says to, let me back up. How many data values are there in the file? So all of these numbers, and every one of these is a data value. All of this stuff. All right, so when you look, you've got this column is 1, 2, 3, 4. There's a bunch of columns there, right? And then you get down, and each column looks like it has 62 data values down this way, and then you got a bunch of those. So again, all of these, right? So you got to figure that out, then how many are there. And so descriptive statistics, let's take a look at that. It says generate descriptive statistics for paper, plastic, and glass, and complete the following table. So you're going to really, we need to find the sample mean, sample standard deviation, and the sample size just for that. So paper, plastic, and glass. And to get descriptive statistics, you go to data, and you'll see here it says descriptive statistics, and paper. We'll do that one first, and then you have to hit evaluate. And it gives you a bunch of stuff. We don't need all of this, so don't paste all of this stuff into your file, project file. We don't, all it's asking for is the mean. We see the mean is right there, right? Standard deviation is right there, right? And it even tells us the sample size. We said there were 62 in there. So paper and then plastic, we can just flip over and get the plastic, evaluate, and you get the mean for that, standard deviation, sample size, and then we need glass, evaluate. The mean, again, there's for glass, and so on. And again, you don't need all this right now, so so good, we got that, and then so it says, did you expect the results here? Briefly summarize, the things that you see up there. Insert a graph with all three box plots from paper, plastic, and glass. So not this. We don't want one by itself. It's saying that you need to get all three box plots, paper, plastic, and glass. So let's look at data and box plot. All right, and so you can do paper, plastic, and glass all together on one box plot. There you go. All right, so we're moving along very quickly, and now, and again, I want you to summarize. So let's look at confidence intervals. Generate a 95% confidence interval about the mean of paper. Okay. And then you're going to do plastic, and then you're going to do glass. So you work with each one of them separately. And when we talk about a 95% confidence interval, we're talking about one group and a particular sample value, sample statistic. In this case, we're talking about the mean. So let's go back to paper and take a look at that data. We went and evaluated paper, and here's the mean for paper, the mean and standard deviation. So that information we already have in our table, right? And again, I'm just making these values up. You're going to do your own. But if I want a 95% confidence interval for that, let's paper, right? I'm going to go to analysis. Analysis, confidence interval, mean, because we said we want to look at the mean. Confidence interval level was 95%, so that's already set forth. The sample size was 62, right? Remember we said, you put the sample size in there, and sample mean, I'm going to make this up because I don't want to do all your work for you. So I'm going to say 44. And sample standard deviation, you're going to look on your paper what yours is. I'm making this up, so remember that. 3.5. Population standard deviation, we don't know. So that's all we have to put in there. Hit evaluate. There's my confidence interval. It runs from 43.11 to 44.89. 2 decimal places is enough. So that's pretty straightforward how to get the confidence interval. And then when you do the plastic, you put the mean for plastic in, and again, I'm making this up. I'm saying, it's 66, and then this is like 2.9, and then evaluate, and then you'll get that, and then you'll do the one for glass, and you're really only just kind of switching these, and then you'll get to it very quickly. Okay, so far, pretty easy. Now, this part here, it says create a graph by illustrating 3 confidence intervals on one graph. Now, we just did the box plots, so this is not the same thing. I can't go in and put confidence intervals just like I'm showing here. So you're going to have to type that in. And all I did was type in group 1 space, 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 space over to the lower number and put a bunch of dashes and then the upper number. Now, this try to make it a little realistic so you know, like this is like roughly 7. And I put 20 here. So 14 is roughly about there. And again, but make it reasonable so it's not like you got way 1 and way up here and it doesn't make sense. So this you can type in, which is using spacing and dashes, and that's it. So that'll take a few minutes to get these 3 you just created here. We want to put them all on one graph. That's all. So these 3 separate things, and you get to compare them. And why we want to compare them is to see, are they overlapping or not? See, these 2 here, it goes from here to here. And then this one, they kind of overlap because 35 starts where it would be in the middle here. Then it goes out and extends more this way. And then this one overlaps that one and that one. So if they didn't overlap, that would be like if there was one down here, confidence interval, and then like one way up here. And there was a gap between where one started and the other one ended. Okay, so you can get that in, and then I asked the question about, do they overlap? What's the difference between confidence intervals and box plots? I mean, box plots, they're showing you the whole distribution of all the data. That's not what this is doing. This is not showing you, oh, there's all my data values. They range from 14 to 42. No, that's what a box plot does. Shows your minimum and maximum and your median and your interquartile range with the box. But confidence intervals are only showing you roughly where that population parameter is. So it's working with the middle of the distribution. And we're saying that the mean, the population mean, which we try to estimate with a confidence interval, is going to be in here in this range. And for group 2, it's going to be in here for this range. And for group 3, because when we collect a sample, we don't know where the population mean is. We know where the sample mean is. And we have to use the sample mean to approximate where the population mean with confidence. And that's what this idea of confidence is here for. A 95% confidence means I'm 95% confident that the true population mean for group 1 is within this range of values here that is built around my sample mean. Okay, hypothesis testing. Let's take a look again. This is pretty straightforward. So let's say that this again is just kind of made up information, and that the weight of plastic is supposed to be basically on average 1.7 pounds. Okay, 1.7 pounds, and you want to test that to see. So there's going to be some population claim. It's not something you make up. Basically, it's something that is legitimately has been created or understood for a long, long time. There's been data collected and they weigh it and they check it all the time. And on average, it always comes out to be 1.7. Okay, so this isn't something that they're just guessing at. For example, let's say that you were guessing what the average systolic blood pressure was. Well, it's really not a guess. We know what the average systolic blood pressure for healthy individuals is typically 120, because we have millions and millions and millions of bits of data out there that will support that. That's a population claim. A population claim isn't something that you make up and you say, I'll test it because I'm going to make this number up. It's something that exists because of lots and lots and lots and lots of data collection. And so through lots and lots of data collection here, they're saying it's 1.7. Now what you're going to do though is state the null and alternative hypothesis. The null hypothesis, we are going to only do what we call two-tailed tests. So it's going to be easy. The null hypothesis is just that the mean is equal to 1.7. Okay, the mean of the mean weight of plastic is equal to 1.7. And the alternative is very easy too, because when you run a two-tailed test, it's just not equal to. So one is equal to, the other one is not equal to. So that's nice and straightforward. Now determine sample mean and standard deviation sample size, which you've already done. Okay, you've already done that. And that's up in your table up here. You already did that stuff. And then determine the likelihood that the population mean is equal to 1.7 using a hypothesis test, mean one sample, 5% level of significance. So let's go and look at that. So this is, going to put this down. We go to analysis, hypothesis test, mean one sample. So that means you collected one sample of data and you're testing the mean. Now we're testing to see if it's will support the idea of 1.7. Okay. So when we go into this, we'll see that StatDisk is set up for the alternative hypothesis. Remember, we said the alternative hypothesis was not equal to. So this says population mean not equal to claimed mean. All right, that's set up right. Significance level, we're supposed to run 5%, 0.05, that's in there. The claimed mean is 1.7, right? Population standard deviation not known. Sample size, again, I'm just going to make this up. We'll say it's 100. You got to go back and look at your data. Sample mean, let's say that the sample mean was 2.8. Again, I don't want to do your problem exactly, so I made that up. The sample standard deviation, I'm going to make it as 1.2. So these three things here are your sample information. This up here is the population, the stated population mean. Now they're calling it the claimed mean, but it could easily be called population, or the claimed population mean would be better, because then they say here, look, population standard deviation. Okay, hit evaluate, and there's the information that you need. You need your p-value, okay, and you need your significance level. That's what you compare. If the p-value is less than the significance level, you reject the null hypothesis that the weights equal to 1.7. Okay, so look at this. The p-value is 0. That's less than 5%. So that means we would reject the null. You always accept or reject the null hypothesis. Okay. All right, good. So let's go ahead and one more. And this last one is the landfill states that 30%, now note, that's not the mean. That doesn't say mean. That says 30% of your neighborhood recycles. You decide to survey your neighborhood and get responses from 45 of your neighbors. 7 of them say they recycle. Run a hypothesis test to see if your sample data supports the claim of 30%. Run a two-tailed test again. So state the null and alternative hypothesis. Well, again, they're stating that 30% recycles. That is the null hypothesis, that the proportion is equal to 30%. And the alternative then would be that the proportion is not equal to 30%. That's it. Very straightforward. Now, are there other types of tests that you can run? Directional tests, yes. But that's not what not for this program, not for what we're doing here, and not for what we'll be doing with the discussion. So that's something that as you go on, you'll get more involved in. But so run a two-tailed test. Determine the proportion. Okay, well, 7 out of 45 was the proportion. Okay. Now, is that close enough to 30%? I don't know. Is it statistically significantly different? That's why we do this, because sometimes you can look at numbers and say, oh, heck, that's definitely not close. But you need a standard. Everybody's got to follow the same standard, so everybody's on the same page. And that's what we're doing, is talking about the standard. No matter what statistics course you take, what statistics you're involved in, this hypothesis testing is the standard. Okay, so now we want to complete a hypothesis test proportion one sample at the 5% level. All right, so going back to StatDisk. Well, this is population mean. We don't want that. Analysis, hypothesis testing, proportion, one sample. So we're doing a proportion, one sample, proportion hypothesis test. Significance level was 5%. That's what they said to set it at. The claimed proportion was 30% or 0.3. Now I'm going to make these up again. Sample size, I said 100. Again, I know it's not 100. I'm just making that up. Number of successes, I'm going to make it 18. Again, I'm guessing, just making that up because I don't want to do all your work for you. So sample proportion is 18%. Okay, that makes sense. Test statistic, critical value. Okay, so we see some numbers there. Those really are the same things. They're just different units of measure of the p-value and the significance level. Okay, our p-value, 0.008. Significance level is 5%. Our p-value is less than the significance level. That means we reject the null hypothesis that the population proportion is 30%, right? There's our claim, or population proportion. We're saying it's 30%, and we are rejecting that, okay, based off of the comparison of the p-value and this significance level right here, right? Okay, that's it.